Hi, hello everybody. So this is the video where we discuss logarithmic functions. So they are the inverses of exponential functions. Now, even though we won't have to graph them, it's good to know that they are the inverses of each other, because when we simplify or solve these or evaluate these expressions, we'll convert the log into an exponential function or equation for us to find what the answer is. So here is the look at the definition of it. May seem a little complicated, but here is the definition of a log function. We use the expression log for log. There's another expression that I will show you. The base is a b value that has to be greater than 0 and not 1. And the x is the expression or value you're trying to take the log of that has to be greater than 0. So when we look at a log problem or log equation or a log expression, in order to find the answer, we will convert to an exponential form in order to find the answer. And this may seem a little complicated, but I'm going to show you how to do it in a much easier way without having to know all of these other details. So let's take a look at these two expressions, for example. Log base 2 of 16, log base 3 of 9. Okay. So log base 2 of 16, log base 3 of 9. Now, the answer to a log question is an exponent. Okay, so what does that mean? It means that when we convert the log to an exponential format, it will look like this. So the question of what is the log of base 2, log base 2 of 16 is 2 to the x equals 16. So in other words, find me the x that you're going to raise the 2 to in order to get 16. And obviously the answer to that is 4. Why? Because 2 to the 4 is 16. So this is basically it. So the log expression looks for an exponent you're going to put right here in order to get the number that you see over there. How about this one? Log base 3 of 9. So that answers the question 3 to the x equals 9. Which number you replace x with to get 9? Yes, 2, right? Because 3 squared is 9. So that's basically the idea of a log. Okay? Let's do the other two here. Log base 4 of 16, log base 5 of 125. Log base 4 of 16, log base 5, 125. So it's the same idea, but now in this case, I have 4 to the x equals 16. So what's my x here? Well, the only number I can replace x with to get 16 on the 4 is obviously a 2. Because 4 squared is 16. Same thing here. This translates to 5 to the x equals 125. So I'm looking for this number to raise 5 to in order to get 125. And obviously that is a 3. Now, one very common case, for example, would be something like this. When these two numbers are the same, the number you're trying to take the log of and the base. So what is the log of base 7 of 7? Well, this is like asking this question. 7 to the x equals 7. Well, what is the value I have to replace x with to get 7? Oh, obviously 1. And this is true for every number, provided that the base is greater than 0 and not 1. So this would be true also if I had 73. Log base 73 of 73, it is 1. And so on and so forth. Okay. The last 3 problems are a little bit more complicated. So let's do one that is similar to this one. And notice that I have this weird letter called E. We'll discuss that in a minute. But I can change it to something similar, such as this, for example. How about log base 8 of 8 squared? Or even better, we'll make it a number that maybe you can understand, maybe simpler number, log base 3 squared. Okay. So if I were to translate this, this would be, what is x once I raise the number 3 to it, and I get 3 squared. Well, this becomes very easy because once the bases are the same, that means that my x is this number over here. So this is obviously 2. So this becomes like a property. When these 2 numbers are the same, all I have to pick is the exponent. So the problem I just gave you now, let's scroll this thing up a little. The problem I just gave you now with a crazy letter here, and that means something, I will tell you later. Since these 2 things are the same, my answer is the exponent. Okay. Similar with this. These 2 numbers are the same. My answer is the exponent. This is like a property. And obviously, the one that I had before, log 7. Now, you don't see anything on top of the 7, but there's like an invisible 1, and that's why the answer is. Okay. Now, there's a couple problems that I have here that are a little bit harder, and we'll discuss them now, but later they'll be more intuitive for us. So log base 9 of 3, log base 2 of 1/8. Okay, so let's take a look at that. Log base 9 of 3, log base 2 1/8. So these are harder because now I have to raise 9 to a power to get 3. This is a little bit difficult maybe for a student, but what is 9 to the 1/2? So if I convert this to a radical, as we've seen before, this is just the square root of 9, which happens to be 3. All right, so this is 1/2. The exponent I have to raise the number 9 to in order to get 3 is 1/2. Similar with this one, 2 to the x equals 1 to the 8th. It's difficult to understand, but if I rewrite 1/8 as 2 cubed, and then I move the 2 cubed to the numerator, that becomes a whole lot easier because now again, as before, I have the bases being the same, just like in this case. And when they are the same, all that you do is pick the exponent. So these 2 cases are a little bit harder, but they will become clear as we move into section 9.3. Okay, so this is the idea of logs, right? So to evaluate all of these simple examples of logs, even though obviously you have a calculator and you can use a calculator, we are looking for the exponent. We'll raise the base 2 in order to get the number. Now, as you can see here, there are 2 special log notations that we need to be familiar with. Okay, and I'm going to write them here. So these are the two special logs. The very first one is log base 10, which we call a common log. So in a common log, we omit very usually the base. So for example, if you see an expression like this, log 100 without a base, that means the base is 10. It's invisible there, but it's 10. So the answer to this is 2, because 10 squared is 100. So common log is log base 10, is normally written without the base. Second one, log base E of something. Log base E is called a natural log. Okay, so when you have a natural log, it is common not to write log base E. It's normal to write ln of something. Let's say ln of e to the 4, as we've seen before. The answer to that is 4. So the base becomes invisible. They don't write it. Okay, they just write ln. So these are the two common bases, a common log, log base 10, which they omit, and log base E, which is natural log, and they write it ln. So these are common bases. We'll see them later. I just wanted to mention them now. So I have them here for you in both cases, right? Log base 10 common base, and log base E, ln x, natural log. It's also omitted. Okay. So the two properties I mentioned before, I think they are somewhat obvious, but you don't have to remember them now. In the next section, we'll go over more of these details, but it's important for you to understand this. So we won't have to graph either the log functions or the exponential functions, but it helps for you to understand that they're inverses of each other, because as you can see here, I use the properties of exponents in order to evaluate these logs, as you see here. Okay, so basically all you have to do in this section is to be able to evaluate these simple logs the way that I did. And then in the next section, we'll cover more specifically about using the properties of logs to either expand or condense using addition, subtraction, and multiplication and division.